Welcome back to Jacobians. In this lecture, we will learn the property 4 of Jacobians. So let us start with an explanation of the property 4. So property 4 says that if u is function of x and y and v is function of x and y, then Jacobians of uv with respect to xy is equal to 0 if and only if u and v are functionally dependent. Functionally dependent means if the Jacobian of uv with respect to xy is 0, then certainly u and v have some relation, and in the reverse direction, if u and v are functionally dependent, means if they can form a relation, then their Jacobian is 0. So this property I just told with the two functions and two variables, but this holds true for any number of functions and any number of variables. In fact, if you have n number of n functions and n variables, then the property holds true. So in general, if u1 u2 un, if u1 u2 un are functions of x1 x2 and xn, then the Jacobian is equal to 0. Jacobian of u1 u2 un with respect to x1 x2 xn is equal to 0 if and only if u1 through un have some functional relation. So in order to have a better understanding of this thing, let us take some example. So as a first example, let us consider u is equal to x minus y by x plus y and v is equal to x plus y by x, so that u and v are functionally dependent. FD means functionally dependent. So we will also find a relation, if exist. So the question will be solved in two steps. First step, you can see that first step is to show if u and v have some relation. This will be shown by the means of Jacobian. And if there is no relation, okay. If there is a relation, the second step is to find the relation. This is a different thing, and there is no certain rule to find a relation. We can just show that there is some relation, but we cannot verify, because verifying a relation is not always so easy. So in this question, this is tested question, so just try to understand. So let us first find the Jacobian of uv with respect to x and y. So this will Jacobian of uv with respect to x and y. This will become 2y. I have already shown this question in some video. So otherwise you can differentiate del u by del x to find 2y by 2i by x plus y whole square and 2x by x plus y whole square, then vx and vy. So v can be simply written as 1 plus y by x, divide the numerator with x, so this is equal to minus y by x square and then 1 by x. So you can simply solve this 2xy this and you will get, you can take 1 by x common from the second row and 1 by 2 by x plus y square common from the first row, so that you will get 1 by x 2 by x plus y square. This is easier that I should write here. So 1 by x plus 2 by x plus y square taken common, so here left is y, and in the next term this is minus x, and then here 1 by x has been taken common, and I think it is better to take x 1 by x square as common. So if you take 1 by x square as common, so here this will be minus y and this will be x. So you can see that yx minus yx, this determinant is 0. So this is equal to 0. This means, because determinant is 0, this means u and v have some functional relation. This u and v have some functional relation. So now with the help of determinant we have just shown that there is some relation, but to find the relation is a tricky thing and there is no certain k rule to this. So let us consider how should we find the relation. So let us try to establish the relation. So u is given as x minus y by x plus y, and v is given as x plus y by x. So you can write is 1 plus y by x, or alternatively you can take y by x is equal to v minus 1. Now in u, divide the numerator denominator with x, so you will get 1 minus y by x and 1 plus y by x. Now y by x can be substituted as v minus 1. So putting this 1 minus v minus 1 and 1 plus y by x is already v. This v is equal to 1 plus y by x, so this is v. So we have got 2 minus v by v, so means if this u is equal to 2 minus v by v, means uv is equal to 2 minus v, or you can write uv plus v is equal to 2, or v u plus 1 is equal to 2. Any of these three is the required relationship between u and v. So let us take another example. Example 2. U is equal to x minus y by x plus y, and v is equal to xy by x plus y whole square. So that u and v are functionally dependent. Also find a relation if exist. Again, you will find the Jacobian of uv with respect to xy. So we have solved too many Jacobians. We have taken many lectures and solved many examples. I hope now you are at your hand to find the Jacobians of these simple functions, and the Jacobian will become 0 because function is tested and it is functionally dependent. So let us try to find for just the completion of the problem, Jacobian of uv with respect to xy. This will become 0, and this is also your homework to verify. Therefore u and v are functionally dependent. So now we will try to find the relation between u and v. So u is equal to x minus y by x plus y, and v is equal to xy by x plus y whole square. Now what we do is square the u. So u is square is what? U is square is equal to x minus y whole square by x plus y whole square. Now x minus y whole square can be written as x minus y whole square. X minus y whole square is equal to x square plus y square minus 2xy, and this can be written as x square plus y square plus 2xy minus 4xy. That means x plus y whole square minus 4xy. So we will make a use of this. So this will be x plus y whole square minus 4xy divided by x plus y whole square, and now you can check this is 1 minus 4 times xy by x plus y whole square, and this term xy by x plus y whole square, this is v. So we have obtained 1 minus 4 times v. So u square is equal to 1 minus 4 times v, or u square plus 4v is equal to 1. So this is our required relation. So we have proved that these functions are functionally dependent and also have some relation. So showing relation is just verifying that determinant says true. Now take another example. Example 3. If u is equal to x plus y by 1 minus xy, and v is equal to tan inverse x plus tan inverse y. So if u and v are not so, but conclude. So conclude if u and v are functionally dependent. Also we will also try to find a relation if there exists. So solution, you can easily find the Jacobian of uv with respect to x and y. So we have find so many Jacobians, so I am directly writing del u by del x. This will become 1 plus y square by 1 minus xy whole square, and 1 plus x square by 1 minus xy whole square. So you can find del u by del x, del u by del y by quotient rule, and vx del v by del x. This is very easy. You can see this is 1 by 1 plus x square and 1 by 1 plus y square. Now you can check, when you take the simplification of the determinant, this will become 1 by 1 minus xy whole square minus 1 by 1 minus xy whole square is equal to 0. And because Jacobian is 0, what does this imply? This means u and v are functionally dependent, means they certainly have some relation. So we will try to find the relationship between u and v. So just take tan v is equal to tan inverse x plus tan inverse y, and this is more compact. This will take more compact form if we take tan inverse x is equal to a and tan inverse y is equal to b. So this will become tan a plus b, means tan a plus tan b by 1 minus tan a tan b. So you can see that if tan inverse x is equal to a, then tan a is equal to x. So this will become x plus y by 1 minus xy, and this is what? This is u. So tan v is equal to u. We have verified that the conclusion by the Jacobian is true. What was the conclusion by the Jacobian? Jacobian is 0, so the conclusion is that u and v are functionally dependent, and we have shown that they certainly have a relation tan v is equal to u. Take another example. U is equal to sine inverse x plus sine inverse y, and v is equal to x square root of 1 minus y square plus y square root of 1 minus x square. If u and v have some relations, find if so. We have to see if u and v have some relations. So this will be done by Jacobians. And if there are some relation, the question says find the relation. So let us try to check it. So first we will find Jacobian of uv with respect to x and y. And you can see it is not very tough to find. Jacobian del u by del x is 1 by square root of 1 minus x square, 1 by square root of 1 minus y square. This, and then when you find del v by del x, this is just 1 minus y square root of 1 minus x square, and this is 0. And what does this imply? U and v are functionally dependent, means surely u and v have some relation. So now we will try to find the relationship. So in order to find the relationship, let sine inverse x is equal to a and sine inverse y is equal to b. So this will give x is equal to sine a and y is equal to sine b. Now check what v is. So from with this terminology, u is equal to a plus b, and what is v? V is x means sine a, and square root of 1 minus sine square b plus sine b square root of 1 minus sine square a. So what is this? Sine a cos b plus cos a sine b, and that is sine of a plus b. So we have reached sine of a plus b. Now just conclude what a plus b is. This is sine u. Why? Because a plus b is u. So this is sine u. So what we got is v is equal to sine u. So this is the relationship between u and v. Finally, we will take one more example. Find a relationship between u, v and w if exist, where u is given by x plus y plus z, v is given by x minus y plus z, and w is given by x square plus y square plus z square minus xz, and this is minus z. So very first thing is that you should find the Jacobian of uv w with respect to x, y, and z, and I am leaving this as an exercise to you to show that this Jacobian is equal to 0. And because Jacobian is 0, this implies u, v, and w are functionally dependent. I have used the short terminology FD. So UVW are functionally dependent. I have checked it that is a 0, and it is your turn to do it as an exercise and show that this Jacobian is 0. Now, what is the requirement? We are required to establish a relationship between UV and W. So check that U square is u square is equal to x square plus y square plus z square plus 2xy minus 2yz minus 2zx and v square is equal to x square plus y square plus z square minus 2xy minus 2yz plus 2xz. So if we sum these two functions u square plus v square, then u square plus v square comes out to be 2 times x square plus y square plus z square, and 2xy will get cancelled, 2zx will get cancelled, and this will be minus 4yz. So if you take 2 common, then you have x square plus y square plus z square minus 2yz, and there is a little correction in the question. This was 2yz. 2yz. So now you can see that we have reached the conclusion that this 2x square plus y square plus z square minus 2yz was w. So this is 2w. So we have established that u square plus v square is equal to 2w. This is the required relationship between u, v and w. So as a concluding remark, we we decide if the functions have some relationship, and this is done by the means of Jacobian. If Jacobian of some functions with respect to their variables is 0, then functions are surely dependent, means they make some functional relationship, and only we decide this with help of Jacobian. And the nature of relationship means actual relationship is decided by the random process. There is no certain rule to see what the relation is, so you can decide as your own with the question to question what the relationship comes out to be for the functions. So it should be it should be kept in mind that Jacobians just tells us if some functions u1 u2 un in n variables x1 x2 xn have some relationship or not, means if Jacobian is 0, there is certainly some relationship, functional relationship between the functions, and if Jacobian is not 0, the functions do not form a functional relationship. So just this fact is told by the Jacobians. To establish the relationship between the functions is not the part of the Jacobian, and it is totally different. Sometimes it is not easy to find the relationship, and even sometimes it is not possible to establish the relationship between the functions. So what is the use of this if sometimes we cannot find the relationship? In industrial processes, in real life processes, engineering and science process, many times this is important to know if the functions are related or not. It is immaterial if they what the nature of relationship they form. So so we decide their dependence and go on to proceed the processes. So, so so it is the concluding remark, and it must be kept remember. And for the examination purpose, because I am making these videos for BTech student mainly, and for examination purpose, the questions are always tested. So if they ask to establish a relation, you must establish a relation, means it is not very tough. However, if you find it tough, you can better is to have a practice. Much practice you have, much easier you can establish the relationship. And we will continue to make further videos on further topics. So I am putting this series of Jacobians to an end here. The most possible next video, next lecture that I will upload on YouTube will be of multiple integrals, and according to the engineering BTech first year syllabus, this is the next topic. So keep connected, stay connected, and wait for the next lecture. Thank you very much.